Let's talk about naming a cycloalkane with two identical substituents. Now, remember, your rule for two different substituents is that you give number one to the substituent that is lower in the alphabet. But let's look at this. When you have two substituents that are the same, we have here two methyl groups. They both begin with the same letter, right? So you can't put number one at the one that is lower in the alphabet. So here's what you do. When you have a situation like this, right, it doesn't matter where you put number one. Here is what matters. What matters is the direction in which you number. You must number in the direction that gives your second substituent the lowest possible number. So let's do that. So I'm going to start number one here, right? That's 1, 2, 3, 4, 5, right? So notice I pick here for my number one, okay? When I did that, my methyl groups were on 1 and 3. All right, cool. Let's do the same thing to show you that I wasn't lying. If we put number one here and we number, that's the key, number in the direction that gives the second substituent the lower or the lowest possible number, then you can start from either one of those substituents. And this is me trying to avoid rejoin the ring. And we're going to get it. Let's just be slow with it. Here we go. So let's give, so the first time around I did it, this was my number one. Let's go with blue. I like blue. Or purple. So here we go. Let's start number one here. If I start number one here and I number in the direction that gives my second substituent the lower or the lowest possible number, you notice you still have 1, 3. So I wasn't lying when I said you could do one at either one of these. Either one of these can be one. The key is number in the direction that gives the substituent, the second substituent, the lowest possible number. Now, let's say I didn't number in the direction that give my substituent the lowest possible number. Of course, it would be wrong. So let me show you what would happen if you didn't do that. So let's go ahead and play around with this structure. So let's say I'm still gonna use purple, but this time around I'm gonna number in the direction that does not give the second substituent the lower number. So doesn't matter where I start with one, I can use either one of these. So let's go here. So if I put one here, 1, 2, and let's just clean up that break. 3, 4, 5. So now, right, me numbering not in the right direction, notice what's happening. My one methyl group is on 1 and the other one is on 4, which is why, please remember this, right? You can put number 1 either here or here. The key is number in the direction that gives the second substituent, right, the lower number. And that right there is 1, 3. Okay? So we are going to name, right? We're going to name 1, 2, 3. That won't work. So let's take these out. I'm just renumbering in the right direction. Okay? So this is 1, 2, 3, 4, 5. So to name, right? On carbon, this is a 3. On carbon number 1, I have a methyl group. So that's 1. You have to locate it, right? Remember that? Then on 3, I have another methyl group. So it's 1, 3. It's 2 of them. So it must be dimethyl, right? And remember, your ring structures, which look like your regular polygon, this is a pentagon, you must write cyclo. They're not straight chains, they're ring. So when you name, you must include cyclo tells me I have a polyhedron, whether it's a pentagon, a triangle, a square, right? And then this particular cycloalkane has 5 carbons. 1, 2, 3, 4, 5. Let me use red for that. This is 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbons. I'm just counting the total number of carbons. So I have five. 5 carbons, your regular alkane with 5 carbons is pentane. So it's 1,3-dimethyl cyclopentane, and that is how you name. If you have two identical substituents, clearly the alphabet is not the route to go because both of them start with the same letter.